Welcome everyone to Wednesday Night at the Lab. I'm Tom Zinnan. I work here at the University of Wisconsin-Madison Biotechnology Center. I also work for the Division of Extension, Wisconsin 4-H. And on behalf of those folks and our other co-organizers, PBS Wisconsin, the Wisconsin Alumni Association, and the UW-Madison Science Alliance, thanks again for coming to Wednesday Night at the Lab. We do this every Wednesday night, 50 times a year. Tonight, it's my special pleasure to introduce to you Daniel Kelm. He's a book artist out of Massachusetts, and he's here as part of Tracy Dreyer inviting him to be here. And Tracy is our glass worker. Tracy, what's your official title?
Scientific glassblower.
Scientific glassblower in the Department of Chemistry, and Tracy's given 3 or 4 of the best Wednesday nights at the labs ever. Daniel's going to talk with us about chemical glassware as functional sculpture. Daniel was born in St. Paul, Minnesota, and went to Highland Park High School there in the cities. He went to the U and studied chemistry and philosophy. And in 1978, he became a book artist. And I'm looking forward to hearing what he has to say and what he has to show us. Would you please join me in welcoming Daniel Kelm to Wednesday Night at the Lab.
Thank you so much, Tom. Thanks for the invitation. Thanks to Tracy for connecting me with Tom so that I could be here tonight and talk with you about chemical glassware and my work. I stood off to the side during that introduction just to see what response there would be about my association with the University of Minnesota. But no one left, so thank you very much. I'm an artist. I was a chemist early in my life, and I'll show you some slides of me in my chemical laboratory. But as Tom said, in 1978, I went from the chemistry and philosophy departments at the University of Minnesota to the library bindery on campus and started making bindings. I wanted to start working with my hands. And I fell in love with books. This is one of my favorite books from 1957, or 1857, I mean. Chemistry for me is all about transformation of materials. And I love how this book has transformed. Now, a collector might look at this and go, oh my God, look at all this staining on the paper. I work very hard as a book artist to do something this beautiful. So I just love that this book, in its environment, was transformed. This is a book by Campbell and Clarence Morfitt, Chemical and Pharmaceutical Manipulations. It's a how-to book on how to design your chemistry lab and outfit it from the mid-1800s. And it's just a wonderful book, and the dedication page is equally beautiful. I love how the works around the typography. Oh, and also the wording in this stuff, dedicated to John Henry Alexander, et cetera, et cetera, et cetera. I just love that sort of thing. So chemistry is messy. And stuff like this can happen when materials interact. So, you know, it might be, in this case, it was probably just water staining, but, you know, you might work with toxic materials, hazardous materials, but up until instrumentation was developed, chemistry was a visual art. You needed to see what was going on. So what better material to contain the chemical reactions than glass, because you can see what's going on. And I've always loved the shapes of chemical glassware. These are shapes that were developed to do certain processes. Now in this array, the glassware is there and it's beautiful forms, but you don't see any of the way of sealing. So later on you'll see how I use luting to seal the junctions between the glassware. Here's Liebig's, the Liebig Museum in Gießen, Germany. And, you know, it's all about routing materials through the glassware. A gas generation bottle on the, in the middle, the trap to keep gas from escaping. The gas is led to a Wolf bottle for a reaction, then a drying tube, and so on. So it's about looking at reactions and about holding the materials so that the reaction can be done without impurities. Now this one, I like this. I think it's also from the Liebig Museum. And the question is, what's wrong with this picture? Anybody see something unusual, kind of out of place here? Kind of the lower right-hand corner, there's a modern graduated cylinder. I don't know why that's there. You know, they don't need that for scale, but I just think it's interesting. I'd love to talk with someone who put that there and find out what was the intention. Here's an array of alembics. Different, you know, they were designed differently for different purposes. The one at the top, middle, and lower left, the vapor would come up from the boiling flask, and the vapor would go into the angled outlet and condense there. But some of the others, like the one at the lower center, has a trough built into it. So the condensation might happen in the alembic, and the material would gather in that trough and then be drained off down the descending exit. Just beautiful forms. I just always have loved these. And I like the associations between glassware and animals. Mattress and ostrich, bear and alembic, goose and retort. Very fanciful. And then the double pelican, or the pelican penetrating its own breast. So this would have been a reflux column of sorts. The vapor would come up and then condense and re-enter the boiling flask at the bottom. And you can see on the title page of John French's The Art of Distillation from 1651, the double pelican. Now the thing that I love about this book is this entry, to make the representation of the whole world in a glass. Now that sounds pretty cool, right? I would definitely want it to do this. Take the purest salt niter as much as you please, and tin half as much. So when you mix those together, calcine them, put them into the retort, you'd get a vapor of tin nitrate. It says, annex a glass receiver, lute them together. Well, the luting is the connection between the various parts of the whole train that is in the glassware and the retort. There will be leaves of gold put in the bottom of the receiver, and then put a fire to the retort so that you get the vapors coming over into the receiver, and then take the receiver off and hermetically seal it or seal it completely, and then take a lamp, put it underneath where the gold is in the receiver, and you'll see shapes that represent the sun, moon, stars, flowers, trees, and fruits, indeed even all things, which is a glorious sight to behold. Pretty tempting. And this is the type of apparatus that you use. This is from Johann Rudolf Glauber, and you can see the iron retort. So you would mix the tin and the niter in that, and the receiver is a glass vessel so that you can see what's going on. Then you would take the receiver away, it would have the gold leaf in it, and put a lamp underneath the gold. And what's happening is that the varying conditions of the heat directly below the gold leaf would allow changing patterns by the reduction of the tin nitrate to tin metal. So you could see a silver covered gold, but changing shapes. It would then reoxidize and go into vapor phase. So it'd be a way of creating all these shapes, and I love the imaginative interpretation as representing everything in the world. And these sorts of images really attracted me when I was a kid. The Laboratory of Chemical Wonders, a scientific melange intended for the instruction and entertainment of young people from 1860. So I would look at these sorts of images, and then I created my own lab in the basement. So my sister took this just short by a couple of months of my 11th birthday. And I'm down in the basement making things. I had a Gilbert chemistry set. And Gilbert chemistry sets were okay, but the bottles were pretty small, so you didn't have much chemical. So I would also collect all of the household chemicals. I go to the hardware store. I had a special arrangement with the druggist. And I would get bottles, bigger bottles of things, because I really wanted to, do big experiments. And I would mix things together that you shouldn't mix together, but I was a researcher, I was an experimenter. I wasn't playing around. So this is the book that really guided my early years. Golden Book of Chemistry Experiments, published in 1960 and removed from the shelves by the end of the decade because some adults thought that it gave information that was a little too risky to be revealed to kids. Now, the one nice thing about this book was that it showed both boys and girls. The Gilbert chemistry sets of this period, often the booklet would say, "Hello, boys, welcome to the wonderful world of chemistry." At least here, it was a little more gender neutral. Though notice no protection, no goggles, nothing. This was a different day. I used to watch Mr. Wizard at this time. And I can remember one Saturday morning, Mr. Wizard, he would invite a young boy and young girl from the neighborhood to come and experiment. And one day he made a mercury hammer. He had a mold for the hammerhead, poured mercury into it, put a handle into the mercury, and then put it in the freezer. And just like Julia Child, then immediately pulled out the frozen one that he had put in earlier and proceeded to pound a nail into a block of wood. Well, every time you hit that nail, there was a little squirt of mercury coming out. And that's the kind of stuff that really I love. Times have changed. Kids don't play with mercury as much. In the old days, we used to play with mercury, and there were games with mercury in them. It was great fun. Now, this was my favorite chapter in the book, Chlorine, Friend and Foe. And, there are little passages in red. I love the one in the middle. Note, perform these experiments out of doors or before an open window. Be careful not to breathe fumes. So there's the warning, right? Well, you can kind of see what's coming in my exploits with my chemistry set, right? So second page, Clorox, Saniflush, all of the good chemicals, the reactive chemicals. And that's what I had bottles of down in the basement. And this was the model for my lab table. So I was all set up. And also, there's the chemist without any protective eyewear or anything also. Well, this kind of sums up what happened. Probably just a little while after that photograph that my sister took, I decided I wanted to make perfume. So, an 11, 12-year-old boy, perfume is just anything that smells strongly. So that's where the Clorox and the muriatic acid, the technical grade hydrochloric acid came in. But I wanted to make perfume that had a real fragrance to it. So I gathered black walnuts down the block and ground some juice out of it and made black walnut perfume with black walnut juice, Clorox, and hydrochloric acid. And of course, what happened? Big cloud of chlorine gas filled my lungs, filled my dad's photographic studio, which was in the basement. He was a portrait photographer. I had to go out and walk around the block a couple of times in order to clear my lungs. And then two very important things happened when I got back to the house. First of all, he kicked me and the lab out of the basement. And second of all, which was actually no problem because I went down the block to my friend Bob Shear's basement, and I mean, this would have been in, the middle, early 60s. His mother would take us to the local chemical supplier near the university, and there was a city desk. So if you were 21 or older, you could walk up to the city desk, give them a list of things that you wanted, and they'd sell everything to you. So on one of those lists that Bob and I gave her, there was a pound bottle of potassium cyanide. So it's a miracle that I'm here to do this presentation between the chlorine gas and the potassium cyanide. But the other thing that happened was a friend of my dad's knew enough chemistry to write out the equation for the production of the chlorine. And it was a mind-body experience for me. I still had the memory of the chlorine in my lungs, and then I look at this written equation producing the chlorine, and I was thrilled. It captured me, and I was a chemist. At that point, I really wanted to go into chemistry as a career. So I went to the University of Minnesota, as Tom mentioned, and after about a quarter at the U, they hired me to proctor and grade and teach or tutor, because I'd already been studying chemistry for at least 10 years or more, and I was pretty good at it. So I slid right into a teaching role. And then this was 1969 that I started, and by 1973, 1 quarter short of graduating with my degree in chemistry, I didn't want to leave. School cost $500 a year for fees and tuition, and I wanted to take classes and everything. So instead of graduating, I dropped out for a few months, and then I went back and they hired me to teach organic chemistry labs full-time, which I did for 2 years. It was great fun, and this was the laboratory that I taught in. Now, this is a picture from 1928, but the lab looked the same. Maybe the fume hoods had been upgraded, but I read when I was just in the Twin Cities, an alumni magazine from University of Minnesota that said that they still have all those lab tables in place, and it's only over the next couple of years that they're going to upgrade the chemistry building and switch from a cookbook chemistry type of presentation where students come in and just do set experiments to more of a collaborative research where students as a group would be given a problem and then figure out the experiments to solve that problem. So that means that these lab tables will have been there for probably about 100 years, unchanged. I saw a lot of wonderful events in this class. Especially one day, there were 2 classes. One was using hydrochloric acid, and another one was using ammonium nitrate, and big clouds of ammonium chloride hanging in the air, which turns out to be a laxative. So there were some people running out of the room. So after 9 years at the university, I felt like this guy. I was doing experiments, but I felt like I crawled up into my head, and I really wanted to get down into my body and make things again. So I loved academic life. I did really well. I stayed for a long time. I became a book collector. I would sit and read. Now, this was Minnesota back in the 70s. I felt a little like Faust because I lived in a house that had no insulation in the walls near campus, old house. And I put insulation over the windows. So not only was it cold during the winter, but it was also dark. So I had a walk-in closet. I lined it with books, and I sat there and read all the time. So Faust with his library, and the insulation was books. But I really wanted to be this character more. I love this caption. I don't know who writes these things. Medieval monks and heretics going underground to form a psychedelic subculture. So that was me, the guy stoking the furnace there. So after I got out of academic chemistry, I built furnaces and I started demonstrating transformation of materials. And it always bothered me in a chemistry lab. There would be, students would come in, they'd see lines of purified chemicals in bottles on a sidewall. They didn't know where the stuff came from, and they didn't know how to transform them to safely dispose of them. So it was only the middle part of the whole story. So here I am, 1986 at Hancock Shaker Village, demonstrating distillation of plant oil. And I'd use it as a conversation in environmental issues. I'd say, okay, here's some of the peppermint. I distill some. They could smell the peppermint oil, same odor, but obviously a lot stronger. So we would talk about, where the chemicals come from and how you would transform them to put them safely back into the earth. Now, I always like this comparison on the right. Now, I may be wrong, but I think that's Brandt who discovered phosphorus. So the alchemist in search of the philosopher's stone discovers phosphorus, 1771. And on the left, the alchemist in search of peppermint oil discovers how hard it is to run a furnace. I had a glass furnace, and I'll show you a picture of that next. And I had it in a water bath, so that meant that I couldn't really raise the temperature very high, just up to the boiling point of water. And consequently, I had, just minimal vaporization of the water and the oil. And so I didn't get a lot of product coming over. So I retired that glass still, which had been made for me by a local glass artist in Western Massachusetts, Charlie Carell, and turned it into just a static sculpture. But then I got a little smarter and I started using a copper vessel in a sand bath so that I could raise the temperature of the water and the peppermint to a higher temperature, and I got much more vaporization and much more product. This is me at the Bruce Museum in Greenwich, Connecticut, demonstrating peppermint oil again, because that's a flavor, scent that people really know. It's familiar. And again, talking about transformation materials and chemical and alchemical processes, smelling the oil, tasting the peppermint. This was a really cold day, cold, rainy day. So here I am in my showing my newer furnace. I got an arts grant to do functional sculpture. And I built a furnace, first for use with distillation, but then this is set up for cupellation. You can see the cupel in the muffle oven, that little rounded door at the top. So there's a close-up shot. And cupellation is a very old process where you take impure gold, or gold admixed with other materials, and you incinerate it and calcine it, so raise it to a high temperature, reduce everything that's not precious metal to ash, and then put it in the cupel, which is a bone ash cupel. So I made these bone ash cupels. And this is the symbol the image from Michael Mayer's Atalanta Effusions from 1617. That book has 50 images that represent alchemical processes. Because alchemy wasn't a written science per se, it was handed down through mentorship. You had to go study with someone. And so a lot of the processes were shown visually. So in alchemy, the king represents the male principle, gold, and the sun. The queen would represent the female principle, silver, and the moon. So here we've got the fallen king, or impure gold. Now when I do traditional book arts, I do a lot of gold tooling and edge gilding, so I would save all of my scraps and then refine it, run it through this process. So the fallen king is impure gold. The wolf is lead. So you, as I mentioned before, you incinerate and calcine the scrap and reduce it all to ash, and there's a lot of gold mixed in with it. Then you wrap that in lead foil, put it in the cupel, put it into the furnace, and then in the background you see the result. The gray wolf stays in the furnace or in the cupel, and the rejuvenated king emerges. So here's the result. You've got this bone ash cupel with all the drossy material sitting on the surface or adsorbed into the cupel, and in the center there's a little shiny bead of pure metal. That's the rejuvenated king exiting the fire or the furnace. And I built, as I said, I got a arts grant to build the furnace as a piece of sculpture. So I included it in a show that I had of my work at the Smith Museum College of Art, or the Smith College Museum of Art, along with all of my book work. And you can see the books are non-traditional. I was telling Tom earlier that I used to get heckled on stage when book purists would take a look at all these unusual shapes that I would make, and they would say, it's not a book, which led to an interesting conversation usually. So if you want to heckle, go ahead. But you know, my work transformed from traditional book arts to alchemically inspired work. So I was looking at mythology and sacred geometry, so that's why there are many shapes like this. And I'll say a little bit more about that as we go on. And I called my work alchemy for years because I liked alchemy. It was the most recent pre-scientific revolution worldview that didn't posit a separation between the observer, the alchemist, and the observed. And it was really a very honest interpretation of the environment. You know, the best definition of alchemy that I found was from a chemical dictionary, and it said alchemy is an imaginary science. And I just love that because it does use the imagination. It's just a nice connection between us and the environment. And you know, when I first lived in the area of Western Massachusetts, I was a fellow in the 5-college system for the history of science, teaching alchemy. And then the next year, the committee chairman changed, and they no longer considered alchemy a fit subject for being taught in an Ivy League school. Since then, Bill Newman at the University of Indiana and Larry Principe, I may not be pronouncing his name correctly, have really elevated in their work alchemy to an acceptable level to be taught in academic environments. I was just a little too early and lost my position to do so. Though I taught interterm class in alchemy, and chemistry professors were there, and we'd have a great conversation comparing and contrasting the alchemical worldview and the chemical worldview. So I was getting, because I was calling my work alchemical, a lot of my friends were giving me sorcerer hats, you know, pointy hats, and it just got to be a little too much. So I coined the phrase poetic science, and that's how I talk about the combination of art and science that I do in my work. And in the mid-90s, I was invited with 26 other book artists to be part of a show at the Smithsonian, I think it was June of '95, called Science and the Artist's Book. And each one of us was invited to choose one of the books from the Dibner collection of science and technology at the Museum of American History. So I went down there and I looked at the books and decided to choose Biringuccio's Pyrotechnia, translated on fire arts. And my piece is down in the lower left-hand corner. I did a sculpture, a book sculpture of the Tower of Athenor. And I'll show you how Biringuccio pictures the Tower of Athenor. It was the alchemical furnace. And before the show, the conservators at the Smithsonian wanted all of us book artists to send a sample of materials that we would be putting in our books, because their book and our book was going to be side by side in a case, and they wanted to make sure that nothing that we put into our books was going to harm their old book. Well, one of my friends, a book artist named Tim Mealy, who was also in the show, wrote back and said, please send samples from the old book that will be next to mine. I want to make sure that it won't damage my book. Of course, he never heard back from them. So here's a title page from Pyrotechnia, and as I mentioned, it translates On Fire Arts, published in 1540. This is, and I went down to the Smithsonian and spent time with the first edition that was in Latin. But then as soon as I got back, I found an English translation so that I could read the book. And I really liked this form, the Athanor, the alchemical furnace. Now, a lot of the reactions had to go on for a very long time. So the tower in the center of the Athanor is the self-feeding fuel hopper for the firebox. And then the coals, the burning coals, could be raked into side furnaces. And often there would be a water bath, a sand bath, an air furnace, something like that, where the different elements would moderate the heat of the fire to produce just the right environment for transformation. Now, one of Biringuccio's contemporaries, Lazarus Erker, shows in his book the cylindrical furnaces. So that's the shape that I chose. And I made it out of borosilicate glass. This was a 6-inch diameter, roughly 6-inch diameter borosilicate glass that would have been used for piping. I can remember one of my jobs in the biophysical research laboratory at the University of Minnesota was down in the basement, and all of the pipes were clear glass, borosilicate, and you could see all this stuff flowing through it. It was really pretty cool. So this is called Templum Elementorum, or Sanctuary of the Elements. As I said, the center tower is the firebox, so that's the fire element, with color and symbolism that's representative of fire. In alchemy, red is associated with fire. On the left is the earth furnace, and that has the symbol associated with it, black color. And on the right is the water bath, and that color is white. And then you can see on the backside the air furnace. Now, it's a different material, different element moderating the heat. And even human heat, body heat was used, and dung was used, and all these different environments for different reactions. And when I started Book Arts, I saw a picture of an English bookbinder from early in the 20th century, Cobden Sanderson, who in his studio had an air furnace for heating his brass tools for doing gold tooling. So he had a kerosene lamp on the floor with a flue above it, and then a ring at the top where he could put all of his brass tools with the head of the tool in the flue, so that the hot air was heating it. So just the right temperature for what he was trying to do. One more shot. So each of these cylinders has a book inside it, and the covers of the books are all in patinaed brass. And you can take the book out. So here we've got the books taken out, each of the 4. Fire book in the back with its the shape, or the metal triangle pointing up, because that would represent fire. In the middle on the left is the water book, and on the right in the middle is the air book. That was the one that was sticking out of the furnace, because the operating area would be the hot air rising from that. And you can see a pop-up. So you open up that metal binding, pop up with the symbol for that element, and at the bottom is the earth book. And then there are side panels that open up to reveal the text, the voice of that element. And the Earth book, the column on the left, starts out, I am Earth older than my name. So I tried to write a first-person narrative in the voice of the element, and just alluding to all of the associations that that element has. So these are the four elements that I try to bring to any of my work, whether it's alchemical or chemical or the book arts: personal, historical, aesthetic, and technical. Personal because I love storytelling, and that gives others access. You know, if you tell a story, then someone will listen. If you preach, people will walk away. But storytelling is such a wonderful thing. Historical, connection to the past, very important for me. Aesthetic, good design and beauty. Technical, functionality, materials, and form. And these four elements were revealed to me through two portraits that my father had hanging in the basement. Now, can you recognize who this person is? Pardon?
Madam Sun Yat-sen?
I'm sorry?
Madam Sun Yat-sen?
Madam Chiang Kai-shek.
Yeah, okay.
Yep.
Sorry.
And this was in her during her 1943 visit to D.C. to try to convince FDR to win the war in the Pacific before, put a lot of his energy there rather than in Europe. Well, my dad worked for Backrack Studios in D.C., and he had clearance to go to the White House to take the official portraiture. He joined the Navy shortly after this. But these two photographs hung in the studio, the one that I had filled with chlorine gas, and I would look at them, and he would tell me the story of taking these pictures. So that was the personal element, the personal connection. And here, Eleanor Roosevelt wasn't even supposed to be, her photograph wasn't supposed to be taken, but my dad had a nice 5-minute conversation with her while Madam Chiang Kai-shek was interviewed. So he convinced the two first ladies to pose together, and Eleanor Roosevelt is kneeling on the grass next to the bench. So my dad told me a story of talking with her and taking the photograph, and then the historical element. This was an important time, 1943, the war is raging. The aesthetic, I loved the composition that my dad did here. It was an impromptu thing. It wasn't planned. When he did the portraits of the Supreme Court justices, the stylist had already positioned everybody, and my dad just walked in and snapped the shutter. He had no control over the composition. But then also the technical side. I fell in love with chemistry watching my dad develop black and white prints in the darkroom, which was right next to, at least early on, was right next to my laboratory. And I would stand there and just watch that image come to life, to develop on that piece of white paper, and I thought, this is pure magic. And that's why I set up my lab right outside his darkroom. So I want to make a point for preserving old apparatus. And I'm using the Kali apparat here, the potash bulb, as an example because its form has become iconic. Little background first. The Kali apparat, or the potash bulb, was developed by Liebig in Germany in the mid-1800s as a much faster way to do chemical analysis of organic compounds, because you could burn in a controlled fashion the compound, carbon dioxide would be released, and up until this time, it was a volumetric determination, but different barometric pressures, the volume would shift, and also you might lose some of the gas. Remember those trains of glassware to contain glassware, or the gas, it may have leaked, but so it was difficult to do a fast analysis that was accurate volumetrically. With the coleoperate, you would put potassium hydroxide in the glass, and you'll see a picture of an actual one. And then any of the carbon dioxide in the gas from the combustion tube would be absorbed. It would react with potassium hydroxide, be converted to potassium carbonate or bicarbonate, and then that could be weighed. So it's called a gravimetric technique for analysis. Much more accurate, very fast. So really transformed organic chemical analysis. So I love this first day issue of the 75th anniversary of the American Chemical Society. And you can see there's a coleoperate on the, in the ACS symbol. The thing that I really love about this, look at the date, September 4th, 1951, 9 a.m. Well, allowing for time zone changes. I was born in St. Paul. This was almost exactly when I was born. So it was in the stars that I would become a chemist, at least for some part of my life. And I did this talk at the, well, it was the Chemical Heritage Foundation in Philadelphia some years ago, and someone in the audience recognized this guy's name, Percy C. Magnus. He was a flavor chemist. So I was meant to be a chemist. So here's the ACS symbol with the coleoperate. And when I was in Portland, Oregon, quite a few years ago now, I went to a glass exhibition, and one of the local glass workers had made this reproduction. And you can see it looks just like the device on the ACS logo. But he obviously never saw a real example because it's just flat. And the bulbs, which match the shape and the size of the bulbs on the ACS logo, it wouldn't work properly. It's just not right. But it shows up. This you can see a little bit, you know, the bulbs are the right size. This is Chemistry Library at Yale and Sterling Chemistry Laboratory at Yale also. Here you start to see the actual shape of it with the relationship of the bulbs, but it got flattened down if you don't know the real one. So here's an example from my collection of a German-made coleoperate, and Tracy in his glass classes here, that's one of the things that you have students make, right? Yeah. It's just wonderful to see the real thing. And I found this, I was invited to go up to Vermont to visit a woman whose father and grandfather had been German-trained chemists, and they had passed, and she still had a lot of their books and a lot of their apparatus. And there were two things that I had always been looking for. One was one of these potash bulbs, and the other was a Plattner blowpipe for blowpipe analysis of minerals. And I walk into the garage where all this stuff is, and they're sitting right on top of the pile, both of them. It was spectacular. So there's the distinction, you know, the one at the top is a genuine item, and the one at the bottom was someone's, you know, honest attempt at reproducing it, but obviously never having seen the real thing. And as I mentioned, it was devised by Liebig in the mid-1800s. And here you can see it at the upper right, hanging within that train. The combustion tube would be in the long device at the center here, flames below to heat up the sample within that. Sometimes they use a gun barrel, so a long metal tube that could withstand the heat. The carbon in the organic compound would react with controlled intake of oxygen, be converted to carbon dioxide, go through a drying tube to get rid of the water, and then through the coleoperate with the potash in it, and then weighed before and after. The weight after would be increased from the weight before just by the weight of the potassium bicarbonate that would have been produced. So here's image of Liebig's laboratory at the top, and then what it looks like today, the Liebig Museum at the bottom. You can see many of the details are still there. And Liebig's classes were the place to go to learn organic chemistry in the mid-1800s. And there was a great effect. I mean, it spilled over into the United States because his students, such as Ammond, the fellow at the top, was one of Liebig's students and then became his assistant, and then came to this country and started Eimer and Ammond, a supply company in New York. You can see the original building top left, and then what it became by 1936 when this catalog was published. And I love these old catalogs because they had a lot of historical information in them. So here's a historical forward talking about the 75 years since the founding of the company, and you know what the company was at the time that this was published. And in this text, talks about you know, the influence of Liebig, and goes on at quite length about all of the aspects, the importance of that experience, and his students coming to this country to start. Now, this was an interesting article that I found in the Times from 1915. Edison's plan for preparedness. Now, up until World War I, universities could import German glassware duty-free because it was going into a teaching environment. But everybody knew that that link was going to be lost with the war with Germany, and Edison was really influential in getting people in this country to talk about war preparedness. There hadn't even been a survey of the industrial capability of the country until this time. So Edison was very influential in starting that. And you can see him in the center of this group with some recognizable names. FDR is on the right. So they started the Naval Consulting Board and the Committee for Industrial Preparedness. And a little bit earlier, you know, in this country, at the beginning of World War I, a number of glass companies got into the business of doing chemical glassware, and Corning was one of them. And I went to Corning and worked in the archive for a couple of days, and found this letter from Frederick Kreisel to Amory Houghton, who was the president of Corning Glass. This was 1898, and he was saying that he wanted to give Corning his expertise to develop chemical glassware, because, and he chose Corning because they had come up with a way of making very precise glass tubing for thermometers. Up until Corning developed this other technique, glass tubing was made horizontally. You would heat the glass and draw it out horizontally. Corning dropped it from a tower, so it went straight down, stayed straighter, and Kreisel was impressed by this. So he came to Corning and brought with him the information about borosilicate glass. That had been developed in Germany in the maybe 1893, something like that. And he was aware of the process and the formula, so he brought it to Corning. And at first, Corning used it as a replacement for soft glass lenses for railroad lamps. You can imagine during the winter, if you turned on a hot lamp on the outside of a rail car or on the locomotive, that the shock of the heat would break the glass, which gave Corning a consistent source of income because they wouldn't last very long, so they had to make lots and lots of them. And then all of a sudden they're using borosilicate glass and they stopped breaking. So they had to find another use for the another income stream. And at first the borosilicate glass was used in cookware. One of the chemists at Corning, one of the glass workers, took a flat-bottomed cylindrical borosilicate glass dish home and gave it to his wife, and she tried cooking in it, and it worked really well. So I've seen reference to Pyrex, spelled P-I-E-Rex, because it was kitchenware to start. But then they started doing the chemical glassware in the, and released it in 1915 as the war was progressing. I love this picture from a book that shows how the flask was blown. So it was hot glass on a is the blowpipe called a pontle, or is that the mark, Tracy, that leaves?
It's a blowpipe.
Blowpipe, okay. So on blowpipe, put down into a mold and blown into shape. And then the flares on top would have been hand-worked. So the Arthur H. Thomas Company claims to have been the first American glass distributor, chemical supply distributor, to offer Pyrex. This is in their, maybe their 1950 catalog. They refer back to in the spring of 1915, after witnessing in the research laboratories of Corning Glass this Pyrex chemical glass, and it was tested along with all the others, American manufacturers, and found to even surpass the German glassware in terms of thermal shock resistance. And so they placed the first order with Pyrex, 150,000 pieces, mostly flasks and beakers. I've been trying to find the, let's see, this was from the Journal of Industrial and Engineering Chemistry, October 1915. Haven't found the original listing yet. And these were the marks that Corning used, 1915, 1918, very simple mark. Now, I'm fortunate enough to have hundreds and hundreds of pieces of the early Corning glass with all four of these marks on it. And then after 1931, it becomes a much simpler mark, and it runs through to about 1960 without any variation. But I have a lot of this early period, and I'm trying to find a home for it. So if anybody has any ideas for me about where to place some of this, I think historically significant glassware, both early Pyrex and then also German glassware. I just happened to be in the right place a number of times where a lot of it came my way. So back to me and as a young fellow in my laboratory. And I just want to thank you all for coming tonight, and I appreciate the opportunity to talk with you. Thank you very much.